Hello everyone, welcome to my talk. I'm Huayao Wu from Nanjing University. In this talk, I will present our work, identifying key features from app user reviews. Nowadays, app stores have become the primary platform for the distribution of mobile applications. An important mechanism of app stores is that they allow users to post reviews to express their opinions. This especially provides a valuable channel for collecting users' feedbacks, but due to the large volume of the available reviews, there is a need to develop approaches that can automatically extract the most useful information from the content of the reviews. Among such useful information in user reviews, an important aspect is the features that the app can provide for users. App developers might want to know which features are more important, so that they can try to improve these features in next releases, and thus make their apps survive in the highly competing app market. In order to analyze the many features of a given app, a primary challenge is the automatic and accurate extraction of app features. Currently, there are already approaches that can extract features from English app descriptions, but the support for Chinese is yet to be investigated. Addressing Chinese app stores could be potentially beneficial for the ever-growing Chinese app market, but this is not easy to accomplish because different linguistic rules and workflows are generally required to process the Chinese text. Second, once a set of features is extracted, the next challenge is to find features that are important for app developers' consideration. This especially requires approaches that can capture the relationships between app features and app rating scores, so that developers can better understand the impact of specific features on the success of their apps. To address the above two challenges, in this study, we introduce the concept of key feature to refer to the features that are highly correlated to app ratings. Such key features exactly indicate features that should be carefully addressed by app developers, as a proper improvement of the features is likely to result in more positive reviews and also fewer negative reviews, and subsequently a higher app rating score. In order to identify such key features of a given app, we leverage the information in both app description and user reviews to develop a novel approach named KEFE. The KEFE approach will first perform pre-process to remove irrelevant and noisy information from app description and user reviews, which is a common step in user review-related studies. Then, KEFE will extract feature describing phrases from app description. This is realized by combining a pattern-based approach and a deep machine learning classifier. Specifically, given a sentence in the app description, KEFE will first segment this sentence into words. Note that this is an additional step required for processing Chinese because there is no clear boundary between words in a Chinese sentence. Then, KEFE will apply post-tagging to label each word in the sentence with its appropriate part of speech. And it will further conduct dependency parsing to review the grammatical relations between these words. With the above results, KEFE then apply a pattern-based approach to extract candidate feature describing phrases. Here, we manually created 10 patterns based on a deep analysis of many app descriptions, where each pattern indicates a combination of grammatical relations for describing app features. At last, given a set of candidate phrases extracted, KEFE will apply BERT, a deep machine learning classifier, to determine whether each of these phrases describes a feature or not. The final set of feature describing phrases is thus produced. After pre-process and feature extraction, we now have a set of features and a set of user reviews. Then, KEFE will perform user review matching to find user reviews that are relevant to each feature. This task is also realized using a BERT classifier, and it will determine whether a given feature is actually mentioned in the content of a given review. Finally, given the set of features and their relevant user reviews, KEFE will apply regression analysis to identify features that have a significant relationship with app ratings. To this end, KEFE will use a regression model to investigate the relationships between the number of all positive or negative reviews received in a period of time and the number of positive or negative reviews that are relevant to each feature. This regression model will produce a p-value for each independent variable, indicating whether the relationship between this variable and the outcome is significant. The features associated with significant variables are then identified as key features. KEFE will apply the above process based on positive and negative reviews separately. Finally, the key features identified are merged together to produce the final set of key features of the given app. In order to evaluate the performance of the KEFE approach, we set out 3 research questions to investigate the effectiveness of the 3 main steps involved in the approach, namely feature extraction, user review matching, and key feature identification. We utilized Qimai, a commercial platform, to create the dataset for this study. Our dataset contains 200 app descriptions extracted from 10 categories of Chinese Apple App Store and user reviews of about 5 years extracted from 5 subject apps. Regarding the effectiveness of feature extraction, we used 150 app descriptions to train the BERT classifier and used the remaining 50 app descriptions for evaluation. Here, for each app description in the evaluation set, we first manually extracted a set of features as golden features. Then, by combining the features extracted by KEFE against these golden features, we can calculate metrics such as precision and recall for the evaluation. According to the results, we can see that KEFE is effective in feature extraction. On average, it can achieve a precision of 82% and a recall of about 75%. Next, regarding the effectiveness of user review matching, we used 5 apps as subjects and selected 2,500 user reviews for each app to train and evaluate the BERT classifier. According to the results, we can see that KEFE is highly precise in matching app features with their relevant user reviews, and an average F measure of 62% is achieved. Lastly, regarding the usefulness of the key features identified, we used the release notes as the ground truth to investigate whether the changes in app ratings are related to the improvements of key features. To this end, we first selected a series of releases with positive and negative changes in app ratings as subjects. Then, for each subject release, we manually analyzed its release note to determine the set of features that are improved. We then applied the KEFE approach based on user reviews received before this release to identify key features. As such, by combining the key features against the features improved, we can calculate the hit ratio of key features. Clearly, a high hit ratio in positive releases indicates that improving key features is more likely to lead to higher app ratings. According to the results, we can see that for all the features described in app descriptions, KEFE will suggest only 27% of them as key features, while for the releases that receive higher app ratings, about 70% of features improvements are related to key features. This finding suggests that the key features indeed indicate features that are important for app developers' consideration. Summing up, in this study, we first introduced the concept of key feature to refer to the features that are highly correlated to app ratings. We then developed a novel approach, KEFE, to identify such key features based on app description and user reviews. We have also conducted experiments on a dataset of Chinese Apple App Store, and the results demonstrate the effectiveness and usefulness of our KEFE approach. Okay, that's all. Thank you very much for your time, and we welcome any comment and question.
Hi everybody, welcome to the session about obtaining information from app user reviews. You saw the presentation that Huayo gave. My name is Patricia Lago. I will be chair of this session, and I'm professor at the Vrije Universiteit Amsterdam in the Netherlands. But that's enough about me. Let's go directly to the Q&A. We already have the first questions in the chat, but feel free to just type in your questions, and if time allows, I will have also a couple of questions for my own, so I hope I will still have time to do that. So let's start. So we have the first question from Sridhar. I hope I pronounced the name correctly. So there are actually two questions about that. The first one is how many of the apps have accurate description? And also the app releases new versions. Is the app descriptions updated? That's intriguing questions. So, Wayo, what do you think?
Okay, thank you. Thank you for the question. For the first question, and I'm not quite sure about whether I understand this question right, but in my opinion, I think all apps or experiments have the accurate description. And maybe someone may think that the feature of an app may have different opinions on the features of an app. But in this study, we use the app descriptions extracted from App Store, and then such a description should be accurate because everyone can see it in the App Store. This is for the first question. And for the second one, whether the app release, or whether the app descriptions will be updated with releases. And the answer is yes. Yes, we indeed observe some app descriptions changes across releases, but such changes are minor, and we mean that even if the app developers will change some sentences in the app descriptions, but the set of features that will be extracted by our approaches are basically the same set. So in our study, we do not consider the changes in the app descriptions, but our approach can be easily adapted to handle such. Basically, if the app description changes, we just need to run our approach based on the new app description, and we follow the same process, and we can get the key features from the user review. And that's my answer.
Yes, actually, this is a very interesting question, I find, because I was wondering, from the KEFE approach, you have these steps. I was wondering if you want just to, let's say, update instead of rerunning the whole pre-processing and feature extraction, how difficult that would be. It's just that you have to change the pre-processing step or something else in your approach?
I'm sorry, I'm not quite get your questions. And can you repeat this?
Yes, I'm. So you in the feature extraction first, okay, you run the pre-processing in the app description, and then you extract the features, right? But if you already have your set of key features, and then the app changes, then you will have to change if you want just to calculate the delta, so the change, instead of restarting from scratch. So how expensive, so how much would you have to change in KEFE, which is indeed Sridhar is what he was curious about.
Okay, I understand. I think there's no more effort required for this situation, because the KEFE approach is automatic, and you give it a new description, and it will produce a set of features. This process is automatic. So if we have a new version and we have a new description, and we just need to rerun the approach, and we can get a new set of features, and also a new set of key features. The set of features extracted might be the same, but it's according to the content in the description. Yeah, so basically this is fully automatic.
Yeah, that might. I think that's a good reflection point, because you basically have to rerun the whole thing, and that's not necessarily not necessary per se. So you might want to think, for instance, how to recognize a new feature from key features that you already have. But I understand this is maybe future works. Maybe this is inspiring for the next step of next version of KEFE.
And I think I can mention one more thing, that if we will have approach that extract features from descriptions, but this step can be done in manual. If the app developers can just provide a list of features, and they can just use the next 2 steps to identify key features. This would be much more accurate, because the first our feature extraction approach does not the very precise appraise for describing features. But if app developers, for app developers, they are easy to produce. So if such a set of features or such a set of golden features is available, the next 2 steps will be much more effective for identifying key features.
Yeah. I think this partially also answers the question of Tin, which is how do you, let's say, map the old set and the new set? Isn't that right? So it's the second part of his comment. If you rerun your tool on a new description, how would you automatically map the old set of features and the new one? So you would have probably in the is a different, let's say, step within the feature extraction that you would have to extract the new ones, right?
I think the point here is we do not try to map the old set and the new set. We have app description, and we extract a set of features, and then we seek to map the set of features to user reviews.
Yeah,
we just need to determine which feature is mentioned in each review, and if the app description is updated, and we just use the new description to identify the features, and then use the new set of features to map the user reviews. So if the release is updated, the description is updated, and we just use the new information in the description. We do not try to reuse the previous content in the previous.
Hey, let me. We are already running out of time, so let me pose one of my questions, because I really want to. So, as far as I understood, you based the evaluation of your approach and the development on the Chinese App Store. So, I was wondering, do you plan to generalize it or port it to a different language, and how expensive would that be in terms of the change?
Let me provide a quick answer. Yes, we want to provide multi-language support, but this is very difficult as far as we know now. Yes, and basically the first step, feature extraction, is for Chinese language, but the second and the third step are available for other languages if they can provide a set of features.
Okay, cool. Thank you very much. It was very, very, very clear. So we